I think you might have remembered this from your high school, how to solve the quadratic equation, right? So let's look at one simple example. Let's say ax squared plus bx plus c is equal to 0, right? So let's try with this case here, which is x squared minus 6x plus 8 equal to 0. Equal to 0. Okay, so we can solve this analytically. And note that in this case, our a is equal to 1, our b is equal to minus 6, and our c is equal to 8, right? Equal to 8. So in order to solve this, there are two ways. You can use the equation, this one is missing here. Okay, this one. So you can use x equal to, one of the x is x squared minus b plus minus b squared minus 4ac over 2a. 2a. So this is the analytical solution. Or you also can do this. Okay, I don't know if you recall this, but you can do this if you want to. Okay, so this is x. Okay, so we need to get minus 6, and we know that this is 8, positive 8, so we can use 2 and 4. 4 times 2 is 8, and we need minus, so minus 6, so minus 2 and minus 4 become minus 6 equal to 0. So the root here is x equal to 2, because, okay, let's do this the longer way. So we can see that in this case, x minus 2 equal to 0. Okay. And x minus 4 equal to 0. So x equal to 2 as one root, and x equal to 4, the other root. So the roots are, in this case, there are two roots here. Why two roots? Because the order is a second order equation. So we have two roots. So one is 2, one is 4. So or you can just straight away use the formula x equal to minus b plus minus b square minus 4ac over 2a. Okay, minus 4ac over 2a. So the first x is x1, x equal to minus b, b is minus 6, which is 6, plus minus 6 square. So minus 6 square is 36. Okay, let's do this again the long way. Minus 6 square minus 4, a is 1, c is 8, square root, and divide by 2. Divide by 2. Okay, so let's see what is this value here. Is this value here? So value here is 6 plus 36 minus 32 over 2, and this is 6 plus square root of 4 divided by 2. This becomes 6 plus 2, which is 8. 8 divided by 2, which is equal to 4. So this is one of the the roots. And the other one is just x equal to 6 minus square root of 4 divided by 2. So 6 minus 2 is 4. 4 divided by 2 is 2. So x is 2. So roots are, okay, x equal to 2, x equal to 4. Okay. So there are two methods here that I showed you. So this is just a review. I think you should know this by now. So it's a straightforward. Okay, so this is what we meant by roots. So we need to set fx, in this case, fx equal to 0 to find the root. So this is the requirement. This is the requirement. Physically or not physically, graphically, we see that this might be 2 and this might be 4, which are the root. I'm not sure if the equation looks like this or it looks like this, but this is the root, the intercept, or the intercept at the intercepts at at x-axis. Okay, intercepts at x-axis. So 2 and 4. So this is what we meant by roots. Okay, so this is the requirement here. This is the requirement. All right, so let's go back to the slide. Okay, so we showed you how to use this equation. Use this equation. Okay, so the next one is the next slide is, okay, so graphically, this is what the example. So we have a first order function. So when we have first order function, we have only one roots. Okay, so this is the one root. So root for second order or quadratic function, we have two roots. Okay, so just like just now, we have x squared plus what was the question just now? Minus 6x plus 8. Minus 6x plus 8 equal to 0. So there are two roots. Okay, there are two roots. So look at this. The roots are minus 2 and 4. Right? So two roots because of x square here. The order is second order. So the same thing that we can say about the other equation, in this case third order or cubic function, we have three roots. We have three roots. So the equation, if we factorize it, it will be something like, that looks something like this. So x, 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 okay. So there's 1, 2, 3 roots. In this case, we have 1, 2 equal to 0. There are two roots. In this case, we have only one root. One root. Okay, so let's look at this equation. Okay, so this is, we know the order is determined by the highest power. So in this case, the highest power in this function is 2, while this one has maybe ax cubed plus bx squared plus cx plus d equal to 0. So the highest order in this equation is 3. So it has 3 roots. It has 3 roots. Okay, so that's one thing. So the order is determined by the highest power. Okay, so in this case it's 3. In this case it's 2. In this case, this is straightforward. Let's say x plus 3 equal to 0. So what is the root? The root is just x equal to minus 3. And what is the order here? This is to the power of 1. So there's only one root. Okay, so if we write this x to the power of 1, so we know it's the power of 1, then we have only one root. Okay, so the other thing that we need to identify is Okay, first we recognize the order. Okay, the order. And the other thing is linear or non-linear. Okay, in this case, this is a linear first order. Linear first order equation. Okay, linear first order equation. Right? So let's go to the next slide. Okay, remember this problem? I think I gave you a quiz. I don't think anyone got the solution. Okay, so it says here, record the velocity of the falling parachutist. Okay, is given by this equation, right? By this equation. So V equal to GMC and so on. Because velocity is explicit, okay, note that velocity is explicit in this case. What is explicit? It means that it can be isolated on the left-hand side. Okay, so V is all alone by itself on the left-hand side. There's no V here. There's no V here. There's no V here. Right? So V is isolated on the left-hand side alone. Okay, so it is easy to compute given the parameters C and M and time T. So if you know what is G, G is known, M, C, and T, then it's easy to calculate V because V is isolated on the left-hand side. But suppose you want to compute the drag coefficient C so that the parachutist of mass M has a particular velocity at time T. So this was the question that I gave you in the quiz. So let's say we know that V equal to 40, T equal to 10, of course, M equal to 68.1, and then G equal to 9.81. So what we need to do is, what is the value of C? Okay, let's try to solve this equation for C. Let's try to solve for C. And we know our problem here is that V equal to GM over C, 1 minus E minus C over M times T. Right? So try to put C on the left-hand side. Okay, so what can we do here? What can we do? The problem here is that we have C at two different places here. We have C here. Okay, we have C here, and we have another C as the exponent. Okay, as the exponent here. So how can we solve this? All right, so it is not straightforward. It's not easy. This is not easy to solve. Okay, let's look at the slide. It says here that it is impossible to solve the equation algebraically for C. Okay, why? Remember, V can be isolated on the left-hand side, but we are trying to do the same thing. We are trying to isolate C. We are trying to isolate C, which is here and here, on the left-hand side, but we couldn't do it. We could not do it. So since because C has two different locations, C is here, the other one is here, and we cannot put C on, we cannot isolate C on the left-hand side. So C is known what we call as implicit variable. So it is really hard to put C on, it's really hard to isolate C on the left-hand side. So C is known as implicit variable. I think the same thing we can say for M. M also cannot be isolated on the left-hand side. So in this case, M is also an implicit variable. Okay, an implicit variable. So in the case of implicit variable, it's really hard to do it. So how can we solve this? So the way to solve this is, okay, we need to find a value of the variable of interest that will satisfy the equation requirement, right? So what is the requirement? The requirement is that V equal to 40 at time t equal to 10 seconds with G equal to 9.81 and M equal to 68.1. So this is the requirement. This is the requirement. So we know in this case V equal to Gm over C 1 minus E minus C over M T, okay, and this is 40, and mathematically speaking, okay, this is 40. This equal signs mean the left hand side and the right hand side must be equal to 40, right? So what is C? What is C that will make this part, this right hand side, become 40? So that is the requirement here. That is the requirement, right? So how to do this? How to do this? To do this, the simplest way is to guess. Okay, just guess. But you know, guess is not a very systematic way. So we try a value of C until left hand side is equal to the right hand side. Remember that this is 40, this must also equal to 40. Okay, when I put C equal to 12 in this equation, what I get is 46.11. So C12 is not a solution because it is not equal. The left hand side and the right hand side are not equal. So I try with 14. See that now this is 40, this one is 41.61. Okay, better than the one before because it's just not that far from the solution. So it's not a solution, but close. And when I move to C equal to 16, what I get is 37.77. Again, not a solution, but it is moving away from the solution. So we can expect that the solution is between 14 and 16. The solution is somewhere here. Okay, solution is between 14 and 16. Okay, so we have at least have a guess. What is the value of C? Okay, so remember that the requirement is that this one, right? So left hand side is 40, right hand side must also equal to 40. So if we rearrange, then this is what we get. Okay, so this is the right hand side just now, minus 40 must equal to 0. So the whole thing here, this whole thing here, if you look at this, is only a function of C. Okay, a function of C. So it's a function of C. So we say that FC must equal to 0. FC must equal to 0. So again, this is the root. This is the root of, this is a function. The function must intercept x-axis and it must become 0 to find what is the C value. So now we have an idea. Okay, we know that somehow, this is FC and this is C. We know maybe it will become like this, and this is the solution to our problem. Okay, what is the value? So this is the root or the solution of this equation here, Okay, so we can write in general this way. Okay, so now we know how to do it. All right, so let's move to the next slide. Okay, let's revisit the previous example. And we know that now this is a function of only C. G is known, M is known, okay, T is known, V is known. So we need to change C. So if I write, um, I write it in a different way. So I put all the known variables, known parameters, then I have C here. So there are two C's. So I use C equal to 12, right? C equal to 12. And what I have is 40. Oh, this is, okay, I'm sorry. This is the other way around. Let me, I will correct this and give it to you. So this one should be 46.11 minus 40. Okay, so it is equal to 6.11. So again, this is the other way around. The other way around. Okay, I'll correct this and give it to you later. Okay, so this is 161. This is minus 2.23. So if you look at this, it is not a solution because it is not equal to 0. This is not equal to 0. And this is not equal to 0. Okay, so from calculation, again, C is most probably between 14 and 16 because there is a change of sign from positive to negative. Okay, the desired value of C is the value that makes FC equal to 0. So if you look at this, okay, if you plot this, maybe this is F C equal to 12, okay, C equal to 14, and C equal to 16. So we know that between 14 and 16, the function cross the x-axis, right? So this is the root here. This is the root. So that is our guess for the moment. Okay. So we have an idea. Where the root is located. Where the root is located. All right. So let's go to the next slide. Okay. So the idea here is to solve this equation. So how can we solve this equation? There are a lot of ways here. So it's mentioned here the outline of the approach. So nonlinear equation solvers. Okay, so let's take a look at our equation. Is this equation linear? Okay, that's one thing. The other question is this equation. What is the order of this equation? So the order of this equation, C here, right? So our variable of interest is C. Look at C and look at C. C is to the power of 1. So we say this is a linear equation. Okay, this is a first order equation. This is a first order equation, which means it has only one root. It has only one root. Okay, so the equation is first order, which means it has only one root. So is it linear or non-linear? Is it linear or non-linear? Okay, so look at this. We know that C is the denominator here, and C is the exponent for our E here. So this is a non-linear first order equation. So basically our equation here is first order non-linear equation. So what we can say here is that because of the first order, we know there's only one C that will solve the solution. Okay. So compared to the previous one, we have a quadratic equation. Okay, we have a quadratic equation. The quadratic equation has two roots because the order is second order. The order is second order. So in this case, this is a first order non-linear equation. And if we look at the approach that we can try to solve, there are three methods here. So this one is the graphical methods, and we have bracketing methods, and we have open methods. So let's try with the simplest one, which is the graphical method, All right, note that the bracketing methods and the open methods are all iterative, which means you have to have a loop. It keeps repeating until you get the solution. Okay, the next slide says, okay, so I'm using graphical methods. I plot FC with respect to C. Okay, so this is the data. So C is my independent variable, 4, 6, and so on. And if you look at this location here, okay, there's a root, and this is between 14 and 16. So this one here. And note that there's a change of sign here. This is positive. This is a negative. Why? Because this thing here, this is positive, and then this is negative, and somewhere between 14 and 16, the line crosses the x-axis. So this is our root somewhere here. So that's the root. Okay, that's the root. So the plot shows that C is about 14.55. Maybe we can take a look at my Excel here. Okay, at my Excel. Why is it not showing on the screen? Okay, let's see. Okay, now this is the Excel here. And this value here, maybe I can zoom in and see. Maybe I can zoom in. Okay, this is, okay. We see this is the value here. So let's zoom in. Okay, zoom in and okay, scroll. Okay, hopefully you can see, or maybe I should zoom in more. Okay, this is already 200% zoom. Okay, here, this is 15. This is 15 here. This is 15. This is 14. This is 14.5. This is 15. So somewhere between 14.5 and 15 is the solution. So my guess was about 14.55. And when I changed that to 14.55, I got 0.49. So what is the root actually? Is this the question here is this error acceptable? Okay, so depending on error acceptance requirement, the solution may or may not be acceptable. It depends on you. So it depends on you. Is this good enough? If the thing is good enough, then you can accept the number. If not, then you have to find another. You need to find another solution. I mean, you need to refine your answers until it met the error requirement. So let's try with some other values. For example, because I already have this spreadsheet here. Okay, I already have the spreadsheet here. Okay, let's change this value to something else. Let's say we change this to, I think just I'll change it to 14.55. Okay, somehow my spreadsheet is not showing on the screen. Okay, give me one second. Okay, so I change this to 14.55. Okay, hold on. Okay, I changed this to 14.55. Okay, and hit enter. It becomes 0.49. So is this good enough? Okay, if this is not good enough, let's try 14.6. Okay, reduce to 0.39. So maybe it's more than 14.6. Let's try 14.7. 0.19. let's try 14.8 and see what is the answer. Okay, let's try 14.8. 14.8. Okay, so maybe it's 14.8. So we cannot get this kind of accuracy. We cannot get this kind of accuracy if we are using graphical method. If we are using graphical method, we cannot get this kind of accuracy. So we need to find a different method to get a better solution. So graphical method will basically aid you, help you in a rough estimate. So in this case, we know it is somewhere between 14.5 to 15. As you can see just now, it is very close to 15, right? Close to 15. So if we change this to 14.9, 14.9, okay, the error is increasing, right? So it is somewhere between 14.7 and 14.8. So just now it was 14.8. We get 0.002. Now let's try with 14.75. Okay, so this is not the solution because the now is increasing. So maybe it's 14.8 something, maybe 14. Let's try 14.85 and see. No. So the best thing that we can do with this spreadsheet is 14.8. Okay, 14.8. So the answer, the solution to one decimal place or three significant figures is only 14.8. Right, 14.8. With graphical method, what we can get is around 14.5. 14.5. So this is the solution. Okay, now let's go back to this slide and see. Okay, so there are some noteworthy observation. So FC is a nonlinear first order equation. Okay, and there is also, because of the first order, we know it only has one root. Okay, why? Because FC is first order in C. Okay, FC changes sign before the root is found. So in this case, all these are positive, 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 and then root, and then negative, 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 negative. Right, so it changes sign before root is found. It might also, in other cases, it might also be something that look like this. Okay, negative, 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 root, and then positive, 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 positive. So that is also another possibilities for finding root. As long as there's a change in sign, then we know root is somewhere. Okay, graphical method is good method to approximate the value of C, just a good approximation. And as you can see just now, it is not as accurate, or it is not as good as what we want. Maybe we want up to 3 or 4 decimal places, but using graphical method, it is really hard to achieve 2 or 3 decimal places. Okay, so let's continue. Oh, that's it. So we are done with the roots of equation concept, and I showed you how to do it using graphical methods. Okay, until the next video, that's it for now. Thank you very much.